What's going on YouTube? And today I'm going to be continuing my MonoGame RPG series. So to jump right into it, the first thing I'm going to get out of the way before we go any further is I'm actually going to rearrange a little bit of how our project works. So as you can see right now, we have all of our graphical properties in our game class, and while that's fine, um, I don't like it to be there. I like it to be in a global class like the drawing class that I can just access whenever, and it keeps it all together. So we're just going to go ahead and literally copy and paste all of this. And we're going to go to our drawing class and we're just going to paste that in here. But because our drawing class is static, we're going to have to change all these variables to static variables, which is fine. And then in our fill rectangle function, there's actually a few things we're going to do, but I'll get back to that in a second. We also need to change these to static. So you should have all of your variables changed to static, and that's all I've done. So then we can go in here and just delete all of this. We don't need any of that now. We also don't need our sprite batch creation in the load content function. We can get rid of that. And lastly, we want to change window.title from title to display.title. Or drawing, sorry. And now, if we go back to our drawing class, we're going to want to create a new function, and this is just going to be our initialization function, so we can set up a few things. Oh, this also needs to be static, there we go. So the first thing we want to do is we want to go ahead and basically do what we just deleted here. So we want to create our graphics device manager, so we'll go ahead and do that. Just reference the game, and then we can go ahead and set our width and height. Go ahead and set that to our width and height variables. And then we can go ahead and set vsync. And we're going to apply. And then after that, we're going to want to do what we did in our load content function of the game, and that's create our sprite batch. But if we do it in this initialization function, this will actually be called before the load content, so if you need to reference things off of initialization from the content, it will be available. Normally, if you tried to reference, for example, you loaded some content here, but you needed to access a sprite in the initialize function, or even maybe above that, like in the constructor, you wouldn't be able to. So yeah, we'll just go ahead and create our sprite batch. Just like that. And then if we go to our game one, we can just go up here and initialize, call that function that we just created, drawing.initialize. And then the parameter is the game class. So now if we run that, it should be the same. Nope. Oh. So in our page game class, we just need to go ahead and change these from g.spritebatch to display.spritebatch. Or drawing, sorry. And now we have the exact same thing, but it's in our drawing class. So the next thing I'm going to do is I'm just going to add one more thing to this, which will help later on. And it's just nice to know. And that's calculating our frame rate in delta time. So right now the way our game works is we have Vsync enabled, so that means our game can't go past 60 FPS, which means our game time is pretty much always just going to be at 60. So we don't have to worry about factoring in processing delay into our movement speeds. So that's what delta's for. And we can just multiply everything we want to move by delta, or anything that involves time by delta, and it will happen smoothly based on the frame rate and delay. So it sounds a little confusing, but we'll just get right into it. So I'm going to create two floats, and I'm going to call them FPS and delta. And then I'm going to create one new function, and I'll call that update. And in here, we can just, we actually need game time as a parameter. And then we can go ahead and set delta to game time.elapsed time.total seconds. So that will give us basically the amount of time in either ticks or nanoseconds each frame. So now to get the frame rate, we just need to divide that value, or we need to take a 1 and divide 1 by that value, so delta. And then if we go back to our game class, we can just call underneath our page update just comment some things. And we can just call drawing.update. And then just as an example, I can go ahead and set the window title. To the frame rate, and if we go ahead and hit play, we can see that our frame rate is now capped at 60, but in the top here. So I'll show you what I mean by the delta time now. So if we move our player and the frame rate's at 60, our player is nice and slow and smooth. And I think this issue actually occurred in one of the prior episodes, and I originally didn't want to use delta time, but I think I will use delta time because it's good to know, and it allows you to unlock your game speed. So the next thing that we'll do is we'll just go ahead and turn Vsync off, and I can show you what it'll look like. So you can see that we have well over 1,000 FPS, probably 2,000 or 3,000, but if I try and move the player, he is very fast, almost completely untrackable. So that's a very easy fix. All we need to do is go to our player class, and in our movement input function, we'll just create a local variable. I'll call this speed, and we'll just make that equal to walk speed times display.delta. Or, I keep saying display, drawing.delta. There we go. And then if we just change, I'll actually change that name because I think that interferes with a abstract name. So yeah, just call that SPD, and we'll make that walk speed times delta. And then we can just replace all the variables for our key presses with speed instead of walk speed. If we go ahead and run the game, our player moves, but he is now way too slow. And that's because when you're using delta time, the values work a little bit differently. So we're going to have to increase this value by quite a bit to get a faster movement speed. So I'll set that to 100. And now if we move around, we're a little bit fast. I could probably raise that more. We'll set it to 300. 350. There we go. Whoops. We got a fluid 3000 FPS fluid player movement based on delta time. So now we can actually get into creating a camera. So first thing we'll do is we'll go ahead and just create a new class. I'll put it in my managers folder, and I'm just going to call this camera. And we'll only need to include the XNA framework. We'll go ahead and create a public class, and we'll create some variables. I'll create one more variable. I'll call that delay. And then we'll create one function. We'll only need one function in here, and I'll just, okay, I'll make a constructor too so we can set our position. So create a constructor with just, oh my bad, this also needs to be a vector2, not a float. So position is a vector2, we have a transform matrix, and our delay field. So now in our constructor, we can just go camera, and then we'll make the parameter a vector2, and we'll just set the position. So now we'll create a function called update. And in here, we're going to want to create a local variable, and that will be for our delta time. So this will just take and set it to delay times drawing.delta. So by default, we can just set delay to like 3. So I'll go ahead and set the initialization value to 3. So then we have our local delay variable. And now we can go ahead and move our camera, so we can go position.x plus equals, and now what we want to do here is we basically want to subtract the new position from the old position. So we actually need to create another parameter for this function, and we'll call that vector2 pose. So right here we can now go pose.x minus the camera x, and then here we're going to subtract the screen size divided in half. Oh, we'll actually have to set that. So get set. No. There we go. Yeah, so we don't need to set that as a private. We can just leave that open. But yeah, right here we're going to subtract the screen size divided in half, and this will basically center the camera. So we'll go ahead and do that by just going drawing.width divided by 2, and then we want to multiply this entire thing by our delta time. And this will add sort of like a slow gradual delay to the camera instead of it being very fixed and mechanical and notchy. So now we're going to do the same thing for the y coordinate. We'll just swap all these out for y and then change display width to display height. And then finally we want to create the transform. So just go ahead and set this to our position.x, position.y, and the z is 0 because we don't need to use that axis. These actually need to be negative. The reason they need to be negative is because I believe when you create a translation, it flips it. So yeah, we're just going to flip these values. So now we can go back to our page game and we can just throw a camera object in here. Start it at just 0, 0. because that doesn't particularly matter. And then right here, we can go... we can update our camera and just set that to player.position, the get position centered function, and game. And then lastly, in our sprite batch begin, we can just add a transform matrix and set that to the cam transform. Now if we run this, we should have a centered player, and it's kind of hard to tell that there's actually camera going on here, and that's because our background is just static green, so it doesn't really look like we're actually moving very much, or at all. But because we added the delay, you can actually kind of tell what's happening. If we didn't add that delay, which I could show you, if we just go ahead and comment out the delay multiplication, it will be completely fixed, therefore you can't really tell that there's any motion, and it doesn't create a very visually pleasing effect. So adding a delay to a camera is a very easy and nice looking thing to do. And we can also play with that value. Yeah, so I think that's all I'm going to do for this video. In the next video, we'll probably work on adding sprites into our game and managing our sprites. But yeah, until then, I'll see you in the next one.